You ever stop and think about it? On a planet bursting with millions of species, we are utterly alone. We are the last human species left. How did that happen? How did we become the last ones standing? Well, that's the incredible mystery we're going to unpack. Picture this, 100,000 years ago, which is just a blink of an eye in evolutionary time, Earth was, well, it was a world of humans. Not just one kind, but many. It was a planet straight out of science fiction with different intelligent human species walking around. So what on earth happened to all of them, and why are we the only ones left to tell the tale? To get to the bottom of this, we need to rewind. We have to go back to the very beginning, to the key adaptations that put our ancient ancestors on a totally new path, a path that would eventually lead to us. Our story really kicks off with technology. 2.5 million years ago, we see the first simple Oldowan choppers. I mean, they're basic, but for their time, absolutely revolutionary. Now look at this timeline. Almost 1 million years go by before the next big thing, the Acheulean handaxe. This wasn't just another sharp rock. It was symmetrical, it was designed, it was a true multi-tool. And then, much more recently, just 200,000 years ago, things get really sophisticated with the level waw technique. This is a complex method where you prepare a stone core just so you can strike off a perfect blade in a single go. This isn't just about making better tools, it's showing us a mind that could plan, visualize, and think several steps ahead. But here's the thing, a brain that can do all that planning and visualizing, it needs a ton of energy. And this is where we hit a fascinating evolutionary puzzle, something called the expensive tissue hypothesis. The core idea is pretty simple. Your body can't afford to run 2 super expensive organs at the same time. You can't have a giant energy-hungry gut and a giant energy-hungry brain. So what was the solution? It was an absolute game changer, controlling fire. Cooking your food is basically like pre-digesting it outside your body. It makes it so much easier to get the calories out, and that meant we could evolve a smaller, much less demanding gut. It was a straight-up evolutionary trade-off. Spend less energy on digestion, and you've got a surplus to spend somewhere else. And here is the punchline. All that freed up energy was funneled straight into the most power-hungry organ we have, our brain. Cooking didn't just change what we ate, it literally fueled the cognitive revolution that made us, well, us. Okay, so with a steady supply of high-octane food, our brains started to grow. And I mean, they grew dramatically. But what was pushing this incredible expansion? What was going on in the world that made a bigger brain such a good investment? Just look at this chart. The growth is staggering. Our brain size pretty much tripled over our evolution. You see a huge jump with Homo erectus, and then it just keeps on going, right up to the roughly 1,400 cubic centimeter brain that we have as Homo sapiens. Now this is where it gets really cool. The timing of this massive brain growth between about 800,000 and 200,000 years ago lines up perfectly with a period of absolutely wild, unpredictable climate swings. Our intelligence wasn't evolving to deal with one kind of world, it was evolving to deal with constant change. It was built for adaptability. And what is the ultimate tool for adaptation? Language. But human language is something special. It's stimulus independent, which means we can talk about things that aren't here right now, the past, the future, things over the next hill. It also has what's called recursive syntax, which is a fancy way of saying we can embed ideas inside of other ideas. You know, I think that he knows that she saw the lion. That ability to build complex thoughts is our true cognitive superpower. So, armed with these powerful new cognitive tools, our super adaptable ancestors started to move out of Africa. But they weren't stepping into an empty world. Oh no, it was already pretty crowded out there. You can just forget that old linear ape-to-man chart you saw in textbooks. 70,000 years ago, this planet was a human melting pot. You had us, Homo sapiens, in Africa and the Middle East. You had the Neanderthals dominating Europe. The Denisovans were out in Asia. And there were several other human species spread all over the place. We were just one player in a very crowded game. And we didn't just live near them. We interacted. We competed, for sure. But the evidence, hidden deep inside our own DNA, is now showing us that we also cooperated and even interbred. And speaking of relatives, one of the most incredible recent finds is Homo longi, nicknamed Dragon Man. This massive skull found in China is at least 146,000 years old. And get this, it might actually be our closest ancient relative. even closer than the famous Neanderthals. This discovery is a total game changer, and it's forcing us to redraw our whole family tree. As one of the scientists, Sijun Ni, put it, finding Dragon Man was like finding our long-lost sister lineage. It's just a profound reminder that our own story is still being uncovered, piece by piece. But we know for a fact that we got very close with another relative. That number you see, 1 to 4%, that's how much Neanderthal DNA is probably in your genome right now if your ancestors came from anywhere outside of Africa. They didn't just disappear. In a very real sense, a part of them lives on inside of us. So what did we inherit from them? Well, genetics suggests that Neanderthal genes might influence things like our skin and hair color, bits and pieces of our immune system, and maybe even our capacity for language through the FOXP2 gene. This was more than just a prehistoric encounter. It had real, lasting consequences that are still with us today. Okay, so if we were living alongside these other humans, sharing territory, even sharing genes, why are we the only ones left? What happened? When you put our survival toolkits side by side, a really important difference jumps out. Neanderthals were brilliant and tough, incredibly well adapted as big game hunters. But Homo sapiens, we were generalists. Our tools got more complex, more symbolic. Our diet was way more varied. And look at this, the social structure. We organized ourselves into these huge, long-distance networks. That difference in social life might have been our ultimate ace in the hole. So how did we hold those massive groups together? One fascinating theory is that we used our unique language for gossip. By sharing information about who's trustworthy, who's a cheat, who's a good partner, we could build and maintain trust with hundreds of people. This allowed for cooperation on a scale no other animal had ever achieved. So what was the final straw for the other humans? There's no single, easy answer. It was probably a perfect storm. First, the climate went haywire again, which would have been tough on more specialized species. Second, with our big social networks and flexible tools, we probably just outcompeted them for food and land. And finally, in a lot of places, they may have just been absorbed into our much larger, growing population, their genes becoming part of our story. So when you look back at this incredible journey, one thing becomes really clear. We didn't make it because we were the strongest individuals, or even the smartest. Our true superpower was our unique ability to cooperate in massive numbers, to share what we learned across huge networks, and to adapt to a changing world faster than anyone else. And that leaves us with a pretty deep question, doesn't it? Our species' defining trait has always been our knack for coming together to adapt to change. Now, as the last human standing, we're facing a whole new set of global challenges. The story of how we got here is a powerful reminder of what it might take to make sure we have a future.